Hello, in this video you're going to be learning how to write formulae. Now there's two methods that you can use for writing formulae. One method is using valencies, the other is using charges on ions. Until you learn more chemistry, the easiest method to do is to use the valencies method. Some of my students love it so much that they've even told me after their GCSE exams that the first thing they did was to write their valencies on their periodic table. It's a really good method. You don't need to understand what the valency means, but for those of you who want to know, it's essentially representing the number of electrons that are used in bonding. All you have to know is that different groups have different valencies. So let's take a look at the periodic table. You have your group numbers across the top. The groups are the vertical columns. So this is group 1, this is group 2. The valencies go with the groups. So to start with, group 1, valency 1. Group 2, valency 2, group 3, valency 3, 4 is 4, and then we go back down again. So essentially you're doing 8 minus the group number. So 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1. Valency 0 for the elements that are in group 0 or group 8 because they don't really tend to form compounds. The transition metals, this block in the middle, have variable valencies, so it can change, and we'll look at how we deal with those shortly. If you've got a periodic table handy, and you will need one, I suggest that you write the valencies across the top so that you know the valencies for each group, as that's going to make the next part of the video much easier for you if you have a record of those valencies. Okay, so then we're going to have a look at how we can use the valencies to write formulae. What we do is we write the symbol for each element. So sodium is Na. Oxygen is O. Note how you must have a capitalised first letter in a symbol. If there is a second letter, it's lowercase, and we must write them like this or you'll get your answers wrong. We then write the valency underneath each element. So sodium's group 1, so it's got valency 1. Oxygen in group 6 has valencies 2. We then cross the valencies over and we write the numbers as subscripts, so little numbers. So we get Na2O. If there's a 1, we don't write it. Just by writing the symbol of the element, that means there's one of them. Magnesium chloride, Mg, in group 2, valency 2. Chlorine in group 7, valency 1. When we cross the valencies over, we get MgCl2. Sodium oxide, Na, group 1, valency 1. Oxygen, group 6, valency 2. When we cross them over, we get Na2O. Magnesium oxide. Magnesium is in group 2, so it's got valency 2. Oxygen's in group 6, so it's got valency 2. We cross them over and we get Mg2O2. As in maths, because they're both the same, we cancel them down, and that gives us MgO as the correct formula. We only tend to see this really with sort of group 2 and group 6, so when they're both valency 2. So just remember, if you get double 2, cancel the 2's down to just give one of each element in the formula. The most common error that people tend to make is forgetting to do the crossing over of the valencies, okay? So don't just write them in, you've got to write them underneath and do that physical crossing over step. As you get more confident, you will find that you don't need to write them underneath, but I do suggest if this is the first time that you're writing formulae, do it and get into good habits, and then you're more likely to get it correct. Right, it's your turn. Please pause the video. Let's take a look at the answers. Here they are. Now, if you haven't got any of these correct, I'm going to go through why. And it may well be that you didn't cross them over. So, potassium group 1, valency 1. Bromine group 7, valency 1. Crisscross, K1Br1, written as KBr. Magnesium group 2, valency 2. Bromine group 7, valency 1. Cross them over and you get MgBr2. Aluminium group 3, valency 3. Chlorine group 7, valency 1. Cross them over and you get AlCl3. calcium group 2, valency 2, oxygen group 2, valency 2, cross and cancel, giving CaO. They are both 2s. Potassium oxide, potassium group 1, valency 1, oxygen group 6, valency 2, cross them over, giving K2O. And then aluminium group 3, valency 3, oxygen group 6, valency 2, cross them over and you get Al2O3. You will get to the point as you practice writing formulae that you will come to recognise which groups your common elements are in, which also makes it a lot quicker. Okay, transition metal examples. I told you already that they've got variable valencies. They can have different valencies. Officially, we call this different oxidation states, but don't worry about that for now. We give the oxidation states or the valency in brackets after the metal. We use Roman numerals to do this, and that's just conventional, and we have to stick to that. Now, this tells us the valency of the transition metal. It's not the number of them in the formula, okay? So it doesn't say that there's 2 coppers in the formula. It says copper has a valency of 2. So when we do the formula, we're doing copper, we're writing the 2 underneath, oxygen group 6, 2 underneath, crisscross and cancel because they're both 2, giving CuO as the formula. In the next example, we've got copper 1 oxide, so that's saying that copper has a valency of 1. Oxygen valency of 2, crisscross, and we get Cu2O this time. So we can see we can have 2 different compounds of copper where we have a different number of coppers in the formula each time. And this is why when we name transition metals, any compound with transition metals, we should include the valency if it can have different valencies. Iron 2 chloride, Fe, valency 2, chlorine, valency 1, crisscross, and we get FeCl2. We do need to remember some transition metals as given in the specification. We need to remember what their valencies are. Silver's valency 1, copper 2, iron can be 2 or 3, and then lead and zinc are both 2. So, as your little shortcut, if in doubt, if the valency is not given, assume it's valency 2, unless it's silver, because silver is valency 1, and that's unusual. Iron they will have to tell you because of the fact it can be 2 or 3. Right, it's your turn. Pause now. Let's take a look at your answers. Here they are. This is what you should have. Let's just whiz through to explain this for you. So iron valency 3 as written in the formula. Chlorine has valency 1. Crisscross, FeCl3. Nickel valency 2. Chlorine valency 1. Crisscross and you get NiCl2. Vanadium 5 oxide. It's quite unusual to have an oxidation state as high as 5, but they can actually go up to 7 for some elements. So vanadium's got a valency of 5, oxygen valency of 2, crisscross, and you get V2O5. Silver chloride. The valency is not given here because you have to remember that silver is valency 1. So it's 1 and 1, so they cancel and it's just AgCl. Lead iodide. Again, the valency is not given here because you have to remember that lead is 2. So 2 for lead, iodine group 7 valency 1. Crisscross and you get PbI2. There are some compounds that you just have to learn the formula for, and in a future video when we talk about ions I'll talk to you about what the charges on these are, but for now the easiest thing to do is know what the formula is and know what the valency is. You can work these out in terms of dot and cross diagrams, but it's massively complicated and you won't have time to do it in the exam, so this is one of the bits that you do just need to memorise, I'm afraid. So hydroxide, oxygen and hydrogen, OH, valency 1. Nitrate, it's the 8 telling you there's oxygen of some sort, so NO3, valency 1. Sulfate, SO4, valency 2. Carbonate, CO3, valency 2. And ammonium, NH4, valency 1. Now, when we use these in our formulae, if we need more than one of them, we have to bracket them, and I'll show you why. So if we have sodium hydroxide, sodium group 1, valency 1, hydroxide from up here, valency 1, crisscross, and we just get Na1OH1, NaOH. No brackets needed. However, if we have magnesium nitrate, Mg valency 2, nitrate NO3 valency 1, when we crisscross, we need to have a 2 here. We can't just put a 2 next to the 3, otherwise it says 32 oxygens, and that's not correct. We want 2 nitrates, 2 lots of NO3. So we write that as Mg brackets NO3 2. And now that says we have 2 nitrogens and 6 oxygens in total, or we can imagine it as being Mg, which has 2 lots of NO3 with it. Okay, so if you need more than one of these compounds where you've got more than one element in, you must bracket it before you put the subscript number in. Right, your turn. Have a go. Pause now. So let's take a look at the answers. Here we are, and we'll just whiz through these. This is putting everything together that you've learnt so far. So potassium, valency 1, hydroxide is OH with valency 1, so the 1s disappear. Magnesium sulfate, magnesium group 2, sulfate SO4 has valency 2, so the 2s get cancelled down to 1s, so we get MgSO4. Sodium carbonate, sodium group 1 has valency 1, sulfate valency 2, so when we crisscross we get Na2SO4. Magnesium valency 2, hydroxide valency 1. When we cross these over, because there's 2 elements in this compound, we need to bracket it, so we get Mg brackets OH2. Ammonium nitrate, ammonium, one of our special ones as well, valency 1, nitrate, valency 1, so the 1s disappear. Copper 2 hydroxide, so that's copper with a valency of 2, hydroxide with a valency of 1, cross them over and we need to use brackets again, giving Cu bracket OH2. Iron 3 sulfate, so that's iron with a valency of 3, sulfate with a valency of 2. So when we cross them over, we get Fe2 brackets SO43. And then copper 2 carbonate, valency 2 for the copper, carbonate valency 2. They cancel down to 1 of each, so CuCO3. And that's as complicated as it gets. That's all you need to understand about writing formulae.